last unit, guys, we were talking about chemical equations, and we were talking about more qualitative aspects of reactions. So identifying types of reactions, identifying what the products were, identifying what the reactants were. Now we're going to get to the quantitative aspects of chemistry and chemical reactions. And the way we're going to do that is by first discussing the mole, because the mole in chemistry is kind of the central unit for all calculations that we will do as far as measurements are concerned. So before I get started though with the mole, I need to give you a real world example. Now, the mole represents a very specific number, and you actually deal with very specific numbers every single day. So if, for example, I gave you 1 dozen, you would automatically know that represents 12, let's say, eggs, for example. 1 dozen, automatically in your head, you know that's 12. If I were to say 1 pear, the number that comes to mind automatically is going to be 2. Okay? So we're going to go back to dimensional analysis, back to crisscross swish, in order to convert between units, just like we did last semester. So for example, if I give you 48 nails, and I ask you, please convert that to a dozen, the unit dozen, so I'm going to crisscross swish. You put the unit that you want to get rid of on bottom, which is nails, and you put the unit you want to get into up top, so it would be dozen. Now, I know that 1 dozen equals 12 nails, and so what I'll do is take 48 and divide it by 12, since 12 is in the denominator. So 48 nails is the same thing as 4 dozen. Now, let's actually talk about the mole. Avogadro came up with this number, and he said, all right, if I say I have 1 mole, what that means is I have 6.02 times 10 to the 23rd either molecules, or if you just have a single atom, atoms. If you have an element. So if you think about this, this is 602 with 23 zeros behind it. So 1 mole has a lot of molecules or atoms in it. But this is nice because now I can talk, rather than having a huge number of molecules, I can say, okay, I've got this many moles. All right, so let me give you an actual example to make this make a little bit more sense. It says in this question right here, number 1, how many molecules are in 2.12 moles of C3H8? So I start with my given, which is 2.12 moles. I'm going to crisscross swoosh. The unit I want to get rid of in this case is going to be moles, so I'm going to put moles on bottom, and I'm going to put molecules up top. Make sure to distinguish between these guys. I write M-O-L-E-C. Okay. Now, I know this relationship. This is just Avogadro's number. So for every 1 mole, there are 6.02 times 10 to the 23rd molecules. And so now, since the 6.02 times 10 to the 23rd is in your numerator, you're going to multiply. So 2.12 moles times 6.02 times 10 to the 23rd. So what I want you to do right now is write out your final answer right here. I'm not going to do it for you. You can calculate that, write your answer, and make sure to have the correct units. So pause me for 1 sec. All right. We're going to move on. You'll do more practice in class. And we're going to move on now to one other concept. Now, when we're in the laboratory, we can't actually measure the number of molecules. We can't sit there and count out molecules. So instead, what we have to do is measure the mass, and we use that with a scale. Now, the really cool thing that we can do is we can relate mass, which is measured in grams, to the number of moles. And so this is how we do it. We calculate what is called your molar mass. Okay? The other really nice thing about this is the fact that the mass of each element, the average atomic mass, is used in order to calculate the molar mass of a compound. So if you look at this example here, it says silver has a molar mass, has a mass of 107.9. What this means is that for every 1 mole of silver atoms, so for every 6.02 times 10 to the 23rd atoms, silver has a mass of 107.9 grams. All right, so I'm just going to show you calculating the molar mass of one compound, and you'll see how nice it is that the periodic table can allow us to do that. So I have aluminum oxide. At this point, you should know to be crossing your charges. Aluminum's +3, oxygen is -2, so your formula is Al2O3. All right. Now, what you need to do is find the average atomic mass of aluminum and find the average atomic mass of oxygen. So if you look at your periodic table, aluminum has an average atomic mass of 26.98. So 26.98. Okay. There are 2 aluminum, so I'm going to multiply this by 2. And then I'm going to add the average atomic mass of oxygen, which is 16.00. And there are 3 oxygens, so I'm going to multiply this by 3. Okay? And so if you do this math, I'm going to take it and put it in my calculator. 26.98 times 2 plus 16.00 times 3, I get 101.96. Now, the units for mass are grams, but this is molar mass. This isn't just mass. So what this is telling us is that aluminum oxide has a mass of 101.96 grams for every 1 mole of molecules. Okay? So the units for molar mass are grams per mole, because it's telling you the mass, grams, for every 1 mole of that compound. All right? So really nice, not too bad. You get to use your periodic table to do it. What I'm going to ask you to do right now is to go, and you're going to complete just the practice for lithium sulfide. So what you need to do is you need to write the formula, and then you need to find the molar mass. Okay, so just for lithium sulfide. And that's it.